AÇU Superport project, building the multimodal dike at the TX1 terminal, northern region of the Rio de Janeiro state, Brazil. In recent years, CEINSA, a Spanish construction company belonging to the Eurofinsa group, has initiated a significant growth and expansion process in the international market, completing all types of public works in countries such as Panama, Peru, Nigeria or Ghana. One of the most important projects to date has been building the multimodal dike at the TX1 terminal of the AÇU Superport in Rio de Janeiro. The project to enlarge the AÇU port is a construction work that entails great technological singularity. It comprises a nearly 2,000 meters long vertical dike that will shelter 3 large mooring berths and a 600-meter long sloped dike that will require building 49 reinforced concrete prefabricated caissons. Sloped dike. The dike, reaching a height greater than 5.5 meters above sea level, will be built in the banked slope modality with a rock core made of elements weighing from 1 to 500 kilos. This core will be topped with a 1.70 meter thick filter layer made of rocks of sizes ranging from 0.5 to 2 tons. The seaward side will be completed with a protection layer made of 3.9 cubic meters core lock type concrete elements that will be erected to a plus 9.6 meter height over the grade, while the land side will be finished with a stone layer comprising rocks weighing 2 to 4 tons. Vertical dike. "49 reinforced concrete caissons will be used to build the vertical dike. To make these caissons lighter, they have been filled with rectangular cells 24 meters wide and between 37.3 and 58.2 meters long, and sunk to 15 and 26 meter depths, depending on the section of the structure. Mooring berth. 3 supersized mooring berths, each measuring 132 meters in length and 25 meters wide, will be built leeward of the vertical dike using 3 concrete caissons per berth. The concrete caissons that will be used at the berth located at the end of the dike, intended for Suez Max type vessels, will be sunk at depths of less than 21 meters below sea level, while those used in the remaining 2 berths, intended for VLCC type vessels, will be sunk 26 meters deep in the water. The entire construction approach to this complex engineering project revolves around the vertical dike, whose design requires state-of-the-art technology and complete control of the building procedures proposed. The construction works of the TX1 terminal de l'AÇU Superport have required the first 9 of the reinforced concrete floating caissons that will be used in the works to be built at the Crinavis dry dock, located at the south encampment of the Bay of Algeciras. The reason for building these 9 caissons remotely is the lack of local facilities that meet the conditions of shelter, safety and space required to deploy all the installations at the implementation area of the TX1 terminal in San Juan de Barra in Rio de Janeiro. Seven of the first 9 caissons made in Algeciras will be incorporated to the works of the vertical dike immediately, while the remaining 2 will be relocated to the same structure once the dike creates the shelter, safety and space conditions necessary to install the Mar della Neto and Mar della Nol floating docks. The 9 caissons built in Algeciras will weigh between 8,100 and 9,600 tons each. Their dimensions will be between 37.28 and 45.10 meters long and between 18 and 25 meters high. The caissons are made of type HA40 reinforced concrete, resistant to seawater and containing 125 kilograms of steel per cubic meter of concrete. Given the geographical location of the project and the particularities of maritime climate, the two caisson-making floating docks, Mar dell'Aneto and Mar dell'Anol, both having enough capacity to build the different concrete caissons, will be deployed to the site. The caissons will be loaded and shipped together in a semi-submersible vessel once they have all been built. Loading the caissons in a semi-submersible vessel. The 9 floating caissons have been loaded and shipped in 2 stages. During the first phase, 5 floating caissons were loaded onto the Black Marlin, a 218 long and 42 meters wide ocean-going vessel. The remaining 4 floating caissons were shipped during the second phase, travelling aboard the Haiyang-Xiaoyu 278, a heavy lift vessel measuring 222 meters in length and 42 meters in width. The loading process has been identical for both phases. Positioning and mooring the semi-submersible vessel at the dike, ballasting it offshore until the loading dock is lowered to 10 meters deep under the water level. Transporting the floating caisson from the Krinoviz dry dock in the south encampment to the Isla Verde offshore breakwater, towing it with 2 void-tied tugboats, each with 35 tons pulling power. One of the tugboats pulls the caisson, while the other pushes it through the waters of the Algeciras Bay, moving at a 3-knot speed. Positioning the floating caissons in the manner and location indicated in the loading procedure, while the semi-submersible vessel is still ballasted and kept underwater. The positioning process is guided by the red marks painted on the caissons for this purpose, so they can be installed in perfect alignment while the vessel remains exactly balanced throughout the entire process. Refloating the semi-submersible vessel until its body surfaces up to the navigational waterline. Drying and conditioning the deck to prepare the material for the anchoring operations. Mounting the fastening and anchoring elements to the deck of the semi-submersible vessel. Laboratory tests carried out to verify the performance of the welding that secures the fastening elements. Final inspection and acceptance of the works done by the insurance company and the maritime authorities. This project has required the qualified and committed efforts of the SAENSA team, coordinating personnel in Spain and personnel stationed in Brazil for a seamless joint effort. In a world that is ever more global, our company is firmly committed to international expansion and local developments, as key elements contributing to the growth and development strategies of the countries where we operate.